Alrighty, now it's time for solving rational, so that leaves out high school, equations. Solving rational equations just means solving equations that have fractions in them or are made up of fractions. So I'm going to show you a new method today. One that will work well with the assignment that you're about to do. How to take care of some of these rational equations. In the previous exercise, what we did was we looked at all the denominators and we came up with a common denominator like 16 or over here 8. And we would multiply the top and the bottom of this one by 2 to turn it into an 8. This is already an 8. Well, these exercises that you're going to be doing on this worksheet, there's a common thing that runs through all of them. And that is that they have a commonality about all the terms. Here's what I mean. See this 16 here? You can get this 16 by multiplying 2 times 8 or 4 times 4. So these two numbers here are actually factors of 16. That kind of is a game changer because that allows us to not to have to multiply the top and the bottom anymore by the same number to change these fractions. And it allows us to multiply the entire equation. We'll multiply the entire equation by the commonality. The commonality here is 16. 16 times 1 is 16. 16 times 2, 8 times 2 is 16. 4 times 4 is 16. So 16 is the commonality, and I'm going to multiply this whole equation by the number 16. Now stop and take a look at that for just a minute. Take a deep breath. Okay. Here's what happens. Now, the more you do these, the more comfortable you get with it, the faster it goes, and the more steps that you can cut out. Now, here's what's happening. This is distributive property for the entire equation. Okay, so if I multiply 16 times 1 over 4, I get 16 over 4. Plus, multiply 1 over 8 by 16, I get 16 over 8. And 1 over 16 multiplied by 16 is 16 over 16. Now I already know that every one of these fractions can reduce because the denominators are all factors of 16. 16 over 4 reduces to 4. 16 over 8 reduces to 2. 16 over 16 reduces to 1. Now this was a bad example because 4 plus 2 does not equal 1. 6 does not equal 1. It can't be. It's the process that I wanted to show you and not necessarily the outcome here. Multiplying the entire equation by one value, well, it gets rid of the fractions for us. How could it be better than that? I'll give you another example. Now we have this equation, and we have x's, we have squares, blah, blah, blah. 3 fractions. X's, x squared. I'm looking at all these denominators and there is a commonality. I can multiply something times 3x and have it equal 6x squared. I can multiply 2x by something and have it equal 6x squared. Here's the commonality right here. Now that's not a professional term. That's not anything that you'll find in the algebra book. That's just a term that I use. Here's my commonality. These two terms both have something in common with this one. So what am I going to do? I'm going to multiply this whole equation by this commonality. 6x squared. When you're multiplying a fraction by a whole number or not a fraction, it's just the tops that get multiplied to this. Again, it's the distributive property. And here we go. 6x squared times this is 6x squared over 3x. Plus 6x squared times 4, 24x squared over 6x squared equals 6x squared times this is 6x squared over 2x. All right, the magic is about to happen. We're going to reduce each one of these fractions. If you have forgotten, let me go over here to the side for just a minute. Let me explain to you what this is. For this fraction right here, I have 6 times x, and 3 times x. And I'm going to mark out the things that are common to the top and the bottom. That pair of x's, 6 divided by 3 is 2. So this reduces to just simply 2x. So this one reduces to 2x. 24 divided by 6 is 4. X squared divided by x squared is 1. So it's 4 times 1, which is 4. Now over here, 6 divided by 2 is 3. X squared divided by x, it's like this right here, is just x. Now, look at this pretty thing. Woo! Man, you work your whole life long to see things that look like this, and here it is. Here it is. Now we solve for x. Move all the x's to the same side. Well, there's 2 x's on the left-hand side of the equal sign. There's 3 x's on the right-hand side. Here's the most x's. So move these over here. I'll mark them out. I'll put minus 2x. So now 4 equals 3x, take away 2x is 1x. There's the solution. Pretty neat, huh? We multiplied the entire equation by the commonality. And when we were done reducing, all of our fractions were all gone away. And then we used the simple Algebra 1 to solve for the unknown. Yes. Yes. All that work on factoring that you did comes in handy on situations like this. 2 numbers that you can multiply together to get 12, but when you add them together you get 8. 2 times 6 is 12. 2 plus 6 is 8. So this quadratic right here must factor into x plus 2 times x plus 6. So let's rewrite that. X minus 1 over x plus 2 plus 5 over x plus 6 equals x plus 3 over x plus 2 times x plus 6. Here's our commonality. You can get this by multiplying this one by x plus 6 and multiplying that one by x plus 2. So we're going to multiply the entire equation by this. Your head is probably spinning. You're probably thinking, oh no, I don't want to do that. Look, it's just going to be a lot of writing, and it's not going to be a whole lot of work. And by work, I mean trying to reason things out in your mind. It's still the distributive property. That times that, and times that. And here's what happens. Okay. For the first multiplication, our denominator is still going to be x plus 2. And on top of that, we have x minus 1, our original denominator, and then these two right here. X plus 2 times x plus 6. Now the plus sign. Our denominator is still going to be x plus 6. And our numerator is going to be this numerator times this. X plus 2 times x plus 6 equals. Now we're ready for this one. Our denominator is going to stay the same. And our numerator will be this times this. All right. Not a lot of thought. A lot of writing? Yes. A lot of thought? No. Keep all the denominators. Keep all the numerators. And just stick right to each one of those numerators the thing you're multiplying by. See. X plus 2 times x plus 6. X plus 2 times x plus 6. X plus 2 times x plus 6. Here's the beauty. This x plus 2 and this x plus 2 cancel out. And I end up with x minus 1 times x plus 6. This x plus 6 and that x plus 6 cancel out. And I end up with this right here. 5 times x plus 2. And over here, this x plus 2 cancels with that x plus 2. This x plus 6 cancels with that x plus 6. And we end up with just simply x plus 3 on this side. Now we combine these. This is multiplication, FOIL. X plus x is x squared. X times 6 is 6x minus 1x, so plus 5x. Negative 1 times positive 6 is negative 6. Plus, now we do this. 5 times x is 5x. 5 times 2 is 10 equals x plus 3. Then you would simplify and solve for x. This is not new. This is new. All right, let's look at a couple more examples. Here's another one. All right. I'm thinking there's going to be some sort of commonality. And here it is. Two numbers that multiply together to get 2. Well, 1 and 2. And two numbers that when you add them together, you get 3. Well, 1 plus 2 is 3. So this must come from x plus 1 times x plus 5. All right, so we're going to multiply this whole thing by x plus 1 times x plus 2, which is what this is right here. All right, I'm going to take a shortcut here. This will save a little bit of writing. When I multiply this to this, I've got x plus 1 on bottom, x plus 1 on top, so this actually reduces to 3 times that. So 3 times x plus 2. If I confused you there, just go back and look at the last problem again, because it's the same process as we did on the last problem. Minus. Now when I multiply this fraction by that, I end up with an x plus 2 on top, an x plus 2 on the bottom. So the x plus 2's are going away, and I'm left with 5x plus 5 times x plus 1 minus 5x plus 5 times x plus 1. That's going to go in brackets because of this minus sign. Equals. Now I'm here. When I multiply this fraction by this, look, I've got an x plus 1 on bottom, x plus 1 on top. X plus 2 on bottom, x plus 2 on top. So all of those go away. Now I'm left with nothing on the bottom of this one, nothing left to multiply on the top, and there we have it. All right, distributive property, 3x plus 6. Now I need to multiply these two together. So 5x times x is 5x squared. 5x times 1 plus 5x is 10x. And then 5 times 1 is 5. Right. So 3x plus 6, still locked in with these parentheses here because of this minus sign. If this were a plus sign, we could just get rid of the parentheses, but it's a minus sign. So we're going to drop the parentheses, change this to minus, this to minus, this to minus. Minus 5x squared minus 10x minus 5 equals 17x minus 2. Combine like terms, I have a 6 and a negative 5. And I have a 3x and a minus 10x. Let's see if that does anything. All right, negative 5x squared. 3x minus 10x is minus 7x. 6 take away 5 plus 1 equals 17x minus 2. Now let's see here. If I change the signs of everything in this equation, I get 5x squared plus 7x minus 1 equals negative 17x plus 2. I'm going to move these x's over here to this side. So plus 17x plus 17x. 5x squared plus 24x minus 1 equals 2. Ew, that's ugly, isn't it? Right. I could move this 2 back over here to change that to 0, and then just use the quadratic formula to solve. Minus 2, minus 2, 5x squared plus 24x minus 3 equals 0. Then use the quadratic formula to solve. I don't think you'll have to do that. I think on your worksheet, these solutions will come just by solving the equations. Okay, lastly, what about one that looks like this? Well, whole number, fraction. I can still use this method here, x plus 1, distributive property. And what that does is it gets rid of the fraction. So I have 5 times x plus 1 equals 7. So the x plus 1 cancel out, plus 2 times x plus 1. Now these are examples that I'm making up in my head, so they may not come out to be the correct solution. They may not even be valid equations. It's the process that I'm trying to show you. So let's see here. 5x plus 5 equals 7 plus 2x plus 2. Combine like terms. 5x plus 5 equals 2x plus 9. Because 7 plus 2 is 9. Move all the x's to the same side. Here's the most x's. So move these over here. 3x plus 5 equals 9. Move everything else to the other side, so move that 5. 3x equals 4. Divide both sides by the number in front of x. X equals 4/3. Okay, give it a shot. I know you can do it. Call me, send me a message, email me if you get stuck, if you need further instruction, if you need help, give me a shout. If you email me, if you email the Gmail account, it's more likely to get to me in a timely manner. My school email account is a little bit delayed, so you can email me through Gmail at ectormath@gmail.com. I have that email address in my cell phone, so if you send me a message that way, I should get it pretty quickly and I'll respond to you as quickly as possible. You can send me a text message. You can call me. You can send me an email through the school email, but I have to check that one from a computer, and sometimes I'm not near a computer. Anyway, I'll help you if I can. Thanks. Bye.